Bismillahirrahmanirrahim. Assalamu alaikum, dear students. You are watching Study with Sheraz, and in today's lecture, we are going to discuss about the electromagnetic spectrum, different regions of the electromagnetic spectrum, and the various type of the molecular transitions that are caused in organic molecules that we extensively study in the spectroscopy. So first of all, we would look at what is the electromagnetic spectrum. So it's the arrangement of different types of electromagnetic radiations in increasing order of their wavelengths. As we know that the electromagnetic radiations are a special kind of radiations which are comprising of the mutually perpendicular electric and magnetic field. And in the first lecture of the spectroscopy introductory lecture, we discussed that the electromagnetic radiations can be characterized by their wavelength, they can be characterized by their frequency, wave number, and the energy. So we can classify the electromagnetic radiations based upon the value of their wavelength or their frequency, wave number, or energy. So most common type of the classification is based upon the wavelength. When the electromagnetic radiations are arranged in increasing order of their wavelength, we get an arrangement of different regions, and that arrangement is basically known as the electromagnetic spectrum. So this is basically the most simple type of the arrangement of various regions of the electromagnetic spectrum, and this is in the increasing order of their wavelength. It can also be mentioned that in some books it is written that the electromagnetic spectrum is the arrangement in decreasing order of their energy, because the radiations at the start are having the shortest wavelength, so they would be having the greatest energy. And whenever we would move toward the end of the spectrum, the radiations are having the highest wavelength and their energy would be lowest. So here we have represented different types of the spectral regions in the form of a line. So this end marks the least wavelength and the highest amount of energy, and this end marks the highest wavelength and the least energy. As you people know that the energy and wavelength are inversely proportional to each other. So first of all, on the above are given the values of wavelengths, and on the below side are given the different spectral regions. So first of all, we would start with the wavelength values, ranges, and their respective regions. So first region is the electromagnetic spectrum starts from the 10 to the minus 4 angstrom. So this is the units are very important, because if you would not mention the unit, you would not get idea about the exact value of the wavelength. So at start, because the wavelengths are very small, so we measure these values in the angstrom. So 10 to the minus 4 angstrom marks the start of the electromagnetic spectrum, and from 10 to the minus 4 to 10 to the minus 3 angstrom, there is the cosmic region. Cosmic rays are basically very high energy radiations that are present at the start of the electromagnetic spectrum. Then up to the 10 to the minus 1 angstrom, there are the gamma radiations. Next is the 10 nanometer. There is the X-ray. So from 10 to the minus 1 to 10 nanometer, there is the X-ray. And from 10 nanometer to 400 nanometer region is known as the UV. At start, we were measuring the wavelength in the angstrom because the values were very small. Next, if the values become little better, we have started measuring in the nanometer, because nanometer is greater unit as compared to that of the angstrom. So from 400 to 800 nanometer, there is the visible region of the electromagnetic spectrum. From 800 nanometer to 10 to the power 3 micrometer. Now the wavelengths are getting bigger, so we are also measuring them in the bigger units. So because micrometer is greater than nanometer, so from 800 to 10 to the power 3 micrometer, there is the IR, infrared region. Up to 1 meter, there is the microwave region, and the last one is the 10 to the power 3 meter. That's the radio waves. As you people are watching here, that it has started from the 10 to the power minus 4 angstrom, and it has reached 10 to the power 3 meters. So you can imagine that 10 to the power 3 meter is how much large. So that's the wavelength of the radio waves, and if the wavelength of radio wave is so large, so you can imagine how smaller would be their energy. Next is the molecular transitions in different spectral regions. As we have a separate lecture on the molecular energy levels, and in that lecture we explained that a molecule is having the various types of energy levels associated with it. We talked about the energy, we talked about the different types of the molecular transitions. So if you have not watched that lecture, the link is provided in the description section. Video is present at the end screen, so you can watch that lecture to get idea of molecular energy levels in a better way. So because a molecule is having different types of the energy levels, so upon the absorption of electromagnetic radiations, it may undergo different types of the transitions. We are going to look that the absorption of a specific spectral region can cause which type of the transition in the molecules. So first of all, if a molecule is absorbing in the X-ray region, the inner shell electron transitions occur. Because the inner shell electrons are very strongly bound, and in order to cause their transition, the very high amount of energy is required if you are going to cause transitions of electrons from the K shell that are very strongly bound, and very high amount of energy is required. So absorption in the X-ray region causes the inner shell electronic transition, and the type of spectroscopy which is studied under these transitions is known as the X-ray crystallography. Basically, it's not much studied in the organic chemistry because this field is concerned with the structural elucidation of the crystals of different types of salts or other solids. The next is the UV visible. The absorption of UV visible radiations causes the transitions of the valence electrons, and the type of spectroscopy concerned with these transitions is known as the UV visible spectroscopy. So, as I have mentioned in the last lecture, that we can give the example of different types of molecular energy levels in this way, that we have these two are E0 and E1 are the electronic energy levels. So R0, R1 and R2 are the rotational energy levels. So you can look here that the energy gap between the two electronic energy levels is so large as compared to that of the rotational energy levels. So you people can imagine that how different types of the radiations are responsible for different types of the transition. So if a molecule has to undergo the electronic transition, it would have to absorb so much energy. And if it has to undergo a rotational transition, the energy gap is very small. So it would absorb the radiations of very small energy. So if a molecule is absorbing in the IR region, infrared region, the energy is small. So only those transitions is possible which are having the very small energy gap. So vibrational transitions are possible by the absorption of IR radiation, and the spectroscopy is called the infrared spectroscopy. The next is the microwave. If a molecule is absorbing in the microwave region, the rotational transitions are possible because the energy of the microwaves is matching with the energy gaps between the rotational energy levels. So rotational spectroscopy is the field concerned with the rotational transitions. And the last one is the radio waves. Very large wavelength, very small energy. So absorption of radiations in the radio waves causes nuclear spin transition. So nuclear spin transitions require very small amount of energy. So the absorption of radio waves causes nuclear spin transitions, and the type of spectroscopy concerned with these transitions is called the nuclear magnetic resonance spectroscopy. That's a very important kind of the spectroscopy in the field of organic chemistry. Basically in organic chemistry we study these three types of the spectroscopies very much. That is the UV visible, IR and NMR spectroscopy. And on this channel we are going to cover all these types of the spectroscopies with the passage of time in the upcoming days. So if you have any question related to this video, you can post your question in the comment section. We will meet in the next video. Up till then, Allah Hafiz.